Hello guys, welcome to my YouTube channel Pharma Learning with Deepika. In our previous videos, we have already studied about the definition of pharmaceutical engineering and the first chapter of pharmaceutical engineering, that is flow of fluid, in which we have covered the definition of fluid flow, properties of fluids and fluid statics, in which we have solved the equation to measure the pressure variation between the two layers of a liquid when it is in the rest condition. So to study in deep, check out the link of my previous video in description. Today we're going to study about the fluid dynamics. So as you all know, dynamics means motion. Fluid dynamics deals with the study of fluid in motion. This knowledge is important for liquid, gels, ointments which will change their flow behavior when exposed to different stress conditions. So the identification of type of flow is important because it is used in the manufacturing of dosage form and handling of drug for administration. So the flow of fluid through a pipe can be viscous or turbulent, and it can be determined by Reynolds number. So Reynolds number have no unit. Why Reynolds number have no unit? Because when we are calculating the equation for Reynolds number, then the upper portion and lower portion units get cancelled out. So Reynolds number have no unit. Reynolds performed an experiment for the determination of the flow of fluid, that the flow is laminar or turbulent. So for this experiment, he took a glass tube and it is connected to a reservoir of a water. Rate of flow of water is adjusted by the wall. As you can see that here he took a glass tube, it is the glass tube, and connected it with the reservoir which is filled with the water. This is the reservoir of water. Then this reservoir is connected with the wall. This is the wall. Then next is the reservoir of colored solution. Is connected to one end of the glass tube with the help of a nozzle. Colored solution is introduced into the nozzle as the fine stream through a jet tube. Here you can see that. So when the velocity of water is low, the thread of the colored water maintains its identity throughout the tube. When water mixed in colored solution, the color stream are seen as parallel line. Flow of water is considered to viscous or streamline or laminar. So what is the laminar flow? Laminar flow is one in which the fluid particles moves in a layer or laminar with one layer sliding over the other. When we increase the velocity of this color stream, then the colored water disappear and entire mass of the water get uniformly colored. This type of flow is called as the turbulent. Reynolds observed a region of an reproducible result between the laminar and the turbulent flow region. This region is termed as the transition region. The region between the laminar and the turbulent flow is called as the transition region. Why we called it as a transition? Because this streamline is changed into the turbulent flow. So the transition is going on. That's why we called it as a transition region. That is the, as you can see, that is the turbulent flow. Here and there it's moving, and in a line it's flowing, so it is called as the lamina. Here also you can see the laminar flow and turbulent flow. So as we all know, that type of flow we can divide it into two parts, that is the laminar flow and turbulent flow. So we'll study the difference between the laminar flow and the turbulent flow. So the laminar flow is one in which the fluid particles moves in layer or laminar with one layer sliding with other. When velocity of the water is increased, the thread of the colored water disappears, of the mass of the water get uniformly colored. Next is, there is no change in the fluid particles from one layer to other. But in case of turbulent flow, there is a complete mixing of the solution and the flow of the fluid is called as the turbulent flow. So the average velocity for the laminar flow is 0.5 Vmax In the case of turbulent flow, the average velocity is 0.8 Vmax. And when the Reynolds number is less than 2000, then the flow is laminar flow. And when the Reynolds number is greater than 4000, then the flow is turbulent. The velocity at which the fluid changes from laminar to turbulent flow, that velocity is called as the critical velocity. When laminar flow changes into the turbulent flow, then that velocity is called as the critical velocity. Now, the Reynolds number. The Reynolds experiment, the flow conditions are affected by the diameter of the pipe, average velocity, density of the liquid, and viscosity of the fluid. The four factors are combined in one way, Reynolds number. So the equation of Reynolds number is du rho upon nu. So du rho equals to inertial force and the viscous force. So what is the inertial force? So basically inertial force is an opposite in direction to an acceleration force acting on a body and equal to the product of the accelerating force and the mass of the body. So the inertial force are due to the mass and the velocity of the fluid particles trying to diffuse the fluid particles. Viscous force is the frictional force due to the viscosity of the fluid which make the motion of the fluid in parallel. So here D denotes the diameter of the pipe, U denotes the velocity of the fluid, and rho denotes the density of the fluid, and nu denotes the viscosity of the fluid. At the low velocities, the inertial force is less when compared to the frictional forces, resulting the flow will be viscous in nature. In other hands, when the inertial force are predominant, the fluid layer breaks up due to the increase in the velocity, hence a turbulent flow take place. So, if the Reynolds number is less than 2000, the flow is said to be the laminar. If the Reynolds number is greater than 4000, then the flow is said to be the turbulent. If the Reynolds number lies between 2000 to 4000, the flow changes between laminar to turbulent. It depends on the condition. So, what are the application of Reynolds number? Reynolds number is used to predict the nature of the flow. The nature of the flow means what? The flow is turbulent or laminar, we can predict. Stokes' law equation is modified to include the Reynolds number to study the rate of sedimentation in suspension. When velocity is plotted against the distance from the wall, following conclusion can be drawn. When we plot the velocity against the distance, then the conclusion drawn are the flow of fluid in the middle of the pipe is faster than the fluid near the wall. At the actual surface of the pipe wall, the velocity of the fluid is 0. So guys, thank you for watching. Meet you in the next video lecture with Bernoulli's theorem.